Okay, so we have, we did last time, we did the inverse functions, okay? Now we're going to do properties of inverse functions. They look complicated, I promise. It's not as hard as it looks, okay? So really important today that if you use a calculator for any of this, which some of this you can, some of it you can't, that you definitely make sure that it's on radian mode. If you have it in degree mode, it's going to mess it up. So anyway, so these are just properties of inverse functions, okay? What's really nice is that they can do some things, but they're restricted, okay? So you'll notice here the sine inverse of sine u is u only if u is between negative pi over 2 and pi over 2. Okay? Now, notice the difference between this one has, the top one has the inverse sine first, and the bottom one has the regular sign first, okay? So if you have the regular sign of the inverse, you can do it if it's between negative 1 and 1. So notice the difference there, okay? That it has to be, the value needs to be, if it's inverse first, it has to be between negative pi over 2 and pi over 2. If it's the regular sign, it's between negative 1 and 1. All right, so let's do an example of these really quick. It said, explain why sine of negative 1 of sine of pi over 6 equals pi over 6 is true, but if you do the inverse sine of sine of pi over 6, of 5 pi over 6, it's not true, right? Well, this value, pi over 6, is between negative 1 and 1. This value is not. So if you were to do this, you will get an answer other than 5 pi over 6, and that's okay. That's a calculator issue. This one right here, I would expect the answer to be pi over 6. I would not want a decimal, okay? If I got a decimal on this answer, I will mark it wrong. This is not a calculator problem. This is a property problem. Okay? All right. So inverse values on cosine and tangent. I'm going to just put these up really quick. We're going to do some examples. Really, it's really not that hard. Okay? So cosine, if we do the cosine inverse first, in order for it to come out to be the same answer, u has to be between 0 and pi. Okay? If we do the cosine first, it has to be between negative 1 and 1. Tangent, if we have the inverse first, the u value has to be between negative pi over 2 and pi over 2. Right? If the tangent comes first, it works for everything. So it might be helpful to have these rules written down so that you can refer back to them. Okay. So this first one, it says the properties of the inverse cosine. So it says cosine of negative 1 is if u is between 0 and pi. Now, this is an interesting problem because it says cosine inverse of cosine of 3.5, right? Well, it's 3.5 between 0 and pi. It's not. It's not. So in a problem like this, I would definitely pull out my handy-dandy calculator and I would figure it out. So you can answer them. They're just not what you would expect. And I didn't write it down. Let me grab my calculator. You should have the inverse functions on your calculator. So cosine negative 1, cosine 3.5, and I get the answer. It's 2.783. Okay, please make sure that you put 2 or 3 decimals, okay? I do not want the answer is 3, that is not correct, okay? 2 or 3 decimals. Okay, here's a tangent one. Now, again, this is, I just wanted to show you these before we get into the complicated ones where we're not using calculators. All right, so the u have to be between negative pi over 2 and pi over 2. Again, same deal, all right? It's not between negative pi over 2 and pi over 2. Now, if it were the tangent comes first, we could do it. It would be 12.4. But in this case, we have to put it in the calculator and figure out what it is. So we're going to go tangent, negative 1, tangent, 12.4. And I get negative 0.1664. Okay. If your calculator is in the wrong mode and it is in degree mode, more than likely it will give you the answer of 12.4. Okay. Or in the last case 3.5, because the values are different for degrees than they are for radians. So make sure that your calculator is in the radian mode. All right, let's do some fun problems. Okay, it said given that u equals tangent negative 1, or the inverse of tangent 4 over 3, find the exact value of sine u and secant u. All right, now I'm going to use triangles and I'm going to use the Pythagorean theorem for these, okay? There are a number of different ways. The book does it a little bit differently, but to me, this is the simplest way to do it, okay? And I'm all about doing things easier if you can. There's no reason to use a complex method when you have a simpler method. So first of all, we need to figure out what the value of all of the legs of this triangle are. So we have a triangle. We know that a tangent of a value, we'll call it v, is 4 over 3. All right. So we know that the hypotenuse rule, or the Pythagorean, not the Pythagorean, but my trig rules tell me that this is opposite over adjacent. Okay. Which means I'm missing my hypotenuse. So my Pythagorean theorem is going to go 4 squared plus 3 squared equals equals c squared, which is my hypotenuse. So I end up with 16 plus 9, 25 equals c squared. So c is going to equal 5. So this is my hypotenuse. So if I were trying to find, so the value of, it really doesn't matter what u is, okay? Because what I'm looking for is the triangle, all right? The angles don't matter at this point. So what I want is I want to know what is sine u, okay? If the tangent of u, this is u, okay? If the tangent of u is 4/3. So if that's opposite over adjacent, my sine is opposite over hypotenuse, 4 over 5. And my secant is going to be my hypotenuse over my adjacent, because the secant is 1 over cosine, so it's 5 over 3. And that's it. Don't make it any more complicated than that. Okay, use your, now I know this is complex, right? We're using different rules. We're using some things that we've learned about our trig rules. We're learning using hypotenuse, or we're using Pythagorean theorem. You've got to be able to look at a problem and say, okay, what tools do I have that I can use to solve these? All right, so that's that. You'll have some problems like that on your homework. All right, so this is an embedded problem, inverse cosine of sine of power 6. So what we need to actually do is to find these values. These are not calculator problems. Again, if you use calculators on this, I'm going to know, because you will have decimals instead of exact answers. So what we need to do is, what is the sine of pi over 6? Well, the sine of pi over 6 is the opposite over adjacent of my pi over 6 triangle. Pi over 6, pi over 3, 1, root 3, and 2. Okay? So my sine of pi over 6 is opposite over adjacent. So I'm going the cosine inverse of 1/2. Well, the cosine of what angle is 1/2? So cosine is adjacent over hypotenuse. So my cosine inverse of 1/2 is pi over 3. Okay, the tangent of the sine of 3 over 5. Okay, now these are again, this is not a unit circle problem, but I can still do this without a calculator. Okay, because what I'm saying the sine of u equals 3/5. Okay, and we know, so what I'm doing is I'm going to find this first of all. So, and it doesn't really matter what u is. Okay, because it's the same thing of saying this is the tangent of the inverse of this. So we're basically saying u equals sine inverse 1 of 3/5. So we're trying to find the tangent of u. All right, so I'm just plugging different variables in there so you kind of see where this is all coming from. So again, sine is opposite over hypotenuse. So I have 3 squared plus b squared, and I keep putting pluses, equals 5 squared. So 9 plus b squared equals 25, b squared equals 16, b equals 4. All right, so this is my adjacent. Okay, so my tangent of u is the adjacent, or opposite over adjacent, so it is 3/4. Keep in mind that we have no idea what u is. We don't care what u is. U does not matter. What I want to know is, what is the tangent of u? And I can find that by finding this, because I already know what the sine of u equals. And I can go this way. All right? You're not finding angles, you're finding trig functions. And you can do that without ever knowing the angles. And that was it. Good luck on your homework.